Today we're starting Unit 2, Logarithmic Equations and Expressions. We did some logs in Algebra 2, but they're always something that's just kind of different. It's a different way of writing an exponential expression. So we have to first really get familiar with how do we change a log into an exponent, or how do we evaluate them, because getting the answer to the log really deals with some kind of exponent or a power. So what is a logarithm? A logarithm is the power to which some number must be raised in order to get some other number. So it's almost like a puzzle. It's a question of taking this base to what power gets me this answer. It's the inverse or the opposite of an exponential function. So here I put an example for you. If I have 2 to the third power equals 8, which is a true statement, right? 2 times 2 is 4 times 2 is 8. I could turn that into a log. It would go log with a base of 2. So this little subscript number, sub meaning it goes down below, that is the base in your exponent. Okay, and then of 8 is how you would say that, and your 8 is what your exponent really equals, is 3. So 3 is actually the power of the exponent. Okay, so it kind of makes this loop saying 2 is the base of my exponent raised to the third power would give me 8. So I can always remember this loop-de-loop. I read it as log with a base of 2, so I can remember that my exponent has a base of 2. I always call this the base, and this the power, and this the of. So log base 2 of 3 is 8, 2 to the cube. 2 cubed is 8. Okay, things that we need to remember, there's 2 special logs. One's called a common log. If you just see log of x, it doesn't look like it has a base or a little number down here, but it does. It's automatically a base of 10. Okay, so this would be log base 10 of x. You need to remember that. Also, they do that because then we have the button, the log button on our calculator we can use for those kind of problems. And then the other special one is called a natural log. They use the abbreviation LN, so natural log of x. It also looks like it doesn't have a base, but it does. It's e. So this would really be natural log of e to the x power. Okay? And something you need to remember, that e is an irrational number. It's on your calculator. It is the second function of the ln button. So if you hit shift ln, that'll bring up your e. I'll put it to the first power just to see what e is. That's the value of it. It's about 2.718281828. It just keeps going. It doesn't actually stop. So this number reminds me of pi. Irrational numbers are numbers that keep going with no repeating pattern and no ending. Okay, so about 2.7 is the value of e. All right, let's try some. Number 1, this would be read as log base 4 of 4 is what? You're trying to figure out what this would be. So to rewrite it, we would say 4 to what power is 4? Well, that's pretty easy. The power would have to be 1. So our answer is 1. Number 2, log base 3 of 27 is what? So I would say 3 to what power is 27? And you could check it on your calculator, but 3 times 3 is 9, times 3 is 27. So it'd be 3 to the third power. So our answer is 3. 3 cubed equals 27. We're wanting the power. All right, why don't you pause and try number 3? Should have gotten 5. I just had to do a guess and check. I just kept multiplying 3 several times, and I found out that 3 to the 5th power is 243. So your answer is 5. Number 4, we see is just log of 1. Remember that this is called a common log. The base is 10. So this would be 10 to what power would give me 1? There's only 2 options to start with a bigger base number and then end up with something smaller. For 1, the power could be 0, because something special happens when we have a power 0, or 2, it could be a fractional power. Sorry, I forgot about the bells. Could be a fractional power that means we're taking a square root. But you should remember that anything to the 0 power is 1. See, it doesn't matter what my base is. Anything to the 0 power is 1. So our answer would be 0. And this one you could actually check on your calculator. If I just put in log of 1, it'll tell me the answer is 0. Okay, number 5. Again, this is a common log with a base of 10. 10 to what power would be 1,000? So that would be 10 times 10 is 100, times 10 is 1,000. My answer would be 3. Number 6, natural log. This actually has a base of e, so this is really the same as log base e of e cubed equals what? So this would be e to what power would give me e cubed. These are actually really easy because the answer's here. E to what power is e to the 3rd power? Well, this would also have to be a 3. So our answer is 3. Number 7, this is really log with a base of e would be what power? So e to what power would be e? E to the 1st power would be e to the 1st power. Our answer is 1. Number 8, we start getting fractions. So we've got log with a base of 10. 10 to what power would be 1 over 10? I'm hoping you remember that negative powers, flip it to the bottom, or if it's on the bottom, it brings it to the top. It's the inverse of the reciprocal. So this would be 10 to the negative 1st power would equal 1 over 10. So our answer is the power negative 1. Number 9, I'll let you pause and try it. Number 9, your answer should be negative 2. 7 to the negative 2nd power is 1 over 49. I just did it on my calculator. Remember, you can go to math and turn it into a fraction to check to make sure. But 7 squared is 49, and I knew I needed to make it go to the denominator. Number 10, this would be log base e. So e to what power would be 1 over e to the 4th? I think I'm going to change that. I want this to come up to the top, so I'm going to make that actually e to the negative 4th. Those are equivalent things, e to the negative 4th and 1 over e to the 4th. So what would this power have to be? Well, it'd have to match and be a power of negative 4. Number 11, this is log base 10. I don't really like how this looks right now. What I want to do is try to make this match this base. So could I rewrite 1,000 as 10 to some kind of power? Yeah. 10, we said 10 cubed. And that's under a 4th root. And then to fix this, our rules with radicals is I can rewrite this as a base of 10 to the 3/4 power. So log base 10 of 10 to the 3/4 power. This is our numerator of our fraction. This index is what's called the radical is our denominator of the fraction. So this is saying 10 to what power would equal 10 to the 3/4 power? Well, they would have to match. So my answer would be 3/4. Okay, number 12. If you want to pause and try it, you can. My base here is 4. So let's try to write 256 also with the base of 4. So let's say 4 times 4 is 16, times 4 is 64, times 4 is 256. So how many 4s did it take me? 1, 2, 3, 4. So 256 is really 4 to the 4th power. And this is all under a 5th root. So then I would rewrite it as log base 4 of 4 to the 4/5 power equals what? 4 to what power would give me 4 to the 4/5 power? Well, this power must be 4/5. All right, number 13, we got natural log, which is log base e. I'm going to rewrite this e as e to the 3/5 power. So I would have e to what power would give me e to the 3/5 power? Well, that would be 3/5. Okay, why don't you pause and try number 14? Should have gotten 1/4. So e to what power would be e to the 1/4 power, since that is a power of 1 on e. All right, the last two are kind of tricky. We've got a base of 27, but I'm seeing my of part has a 9, so it's smaller than what the base is. That means it's going to be some kind of fractional exponent or some kind of square root, cube root, fourth root, something weird. Okay, so I'll show you how to treat these. We'll say 27 to what power is a 9th? I know it's going to be negative because I'm sinking it to the bottom. What I would do, because this is probably going to trick people, is do change of base. We've talked about this before. Change of base formula is what it's really called. It's something you just do on your calculator, so it makes it super, super easy. So let's do it here and let's do it here. We would use the log button. So hit log. And then you want to do of the 1/9 first. So I'll do 1/9. That gets divided by log of 27. So we're doing log of 1/9 divided by log of 27. It's just a way that we can make them have a common log. And then we get this decimal. Let's hit math. Enter, enter. So our answer is -2/3. Which really should make sense. This 27 to the -2/3 means I'm cube rooting 27, which is 3. I'm squaring that, which is 9, but having a negative power makes it go to the bottom, so that's 1/9. So no, this is a bunch of mumbo jumbo. If you don't understand that, just do change of base. Okay, number 16, I'll let you pause and try change of base. Your answer should be 1/7. You'd take log of 2 divided by log of 128. So really what that's saying is 128 to the 1/7 power is 2, and you could check that. Yep, or I could say the 7th root of 128 is 2.